Hi folks, so 2015 here, question 9, your acids and bases. So standard initial questions, define an acid according to Arrhenius. So an Arrhenius acid is a substance that dissociates in water, and you need that. This is your dinner at 6, your lunch at 12, forming hydrogen ions. You know, these are bog standard. A Bronsted-Lowry acid, and write out Bronsted-Lowry is a proton donor. Define pH. Next one. So the pH, put in your equation first of all. And then get the words from that. It's defined as the negative log. You can see the minus in front of it. Write in negative log to the base 10 of the hydrogen ion concentration. I know this is rough, but we're going to do a few questions here. And one limitation of the pH scale is that it's temperature dependent, like all our equilibrium values. Another thing, horse down doesn't work or doesn't apply to very concentrated solutions. It goes outside that range 0 to 14 then. And you'd figure that out if you threw it into this formula, minus log to the base 10 of hydrogen ions. Next bit, we're titrating a sodium hydroxide, which is my NaOH, my Arrhenius base dissociates into hydroxide ions, and ethanoic acid. So it's a weak acid, strong base. Something you would have seen in your vinegar titration. They give us a number of values. So we're starting off with our acid this time, say in our conical flask, and we're dropping the base. Now we don't do that, you know, usually start off with your base in there, but this is what they're telling you in this one. Graph the pH curve, 15 marks out of 50, 30% of the question, and that's what she looks like. I took it from the marking scheme. Make sure you label your axis, you have them evenly spaced. You know, every big box there is 1. Again, every big box down the bottom of our NaOH is 5, and you get a titration curve like that. You know, if we had started with the base at the bottom, it just would have been symmetrical. You would have started off with about up here, gone down. You know, it's the exact same. So be aware of that. But here we're adding our sodium hydroxide. So that should be handy marks for you. Then D part 1. Calculate the initial concentration, so the starting concentration of ethanoic acid. So it has to be below a pH of 7, and we see there at the start the pH was 3.3. Now think of all the information that we have on a pH. pH, use the formula, minus log to the base 10 of my hydrogen ions. Now I know my pH in this is 3.3. minus log to the base 10 of H+, and we're trying to work out the concentration. We're trying to work out the H+ in moles per litre. Now you can use your anti-log, and in order to do that, just bring across that minus. Or remember, you can use that Liverpool beats Newcastle powerful. So log, base number, and power. So the base number, 10, to the power of minus 3.3 is equal to the number, or the hydrogen ions. Or just go shift log and throw in minus 3.3, and we get 5.01 by 10 to the minus 4. This, don't delete it. That's my initial concentration of hydrogen ions. Of hydrogen ions. Now they've asked you for the initial concentration. An initial concentration, I'm thinking of molarity. And I kind of know there's something else to do there, because why else would they give me the Ka value, my dissociation constant? So what I'm thinking of here is gamma. So I'll do it down below. Over here. I'm all over the place in this thing. So hydrogen ions is the square root of gamma. Ka times Ma. Now I know the answer to this from over here. It's 5.01 by 10 to the minus 4. I'm working out my molarity. Why else did they give me my Ka value? Ka in this is 1.8 by 10 to the minus 5. And I've got my Ma. It takes a bit of maths here. We need to get that out of the square root. In order to get that out of the square root, we square both sides. And then to work out Ma, just simply bring this in below. We're dividing by it. It's the exact same as if I had 2x equal to 8. To work out x, 8 over 2. My 2 in this case is just that monstrosity of a number. And that's my molarity, the initial concentration in moles per litre. So I'll just go answer squared over my dissociation, and I get 0.01395. Or 0.014 if you wish, moles per litre. Make use of your graph to reduce the volume of sodium hydroxide needed for neutralization. So neutralization is pH of 7. And when it says make use of your graph, you go across your graph, use a ruler for this, and go down, which they've done, and they've spat out 20. So an answer there of 20 centimeters cubed. Or if you look at this, pH of 7, 19.8, but suppose your graph's not going to be that accurate. And what indicator would you use? So I'll do it down here. So the indicator being used, and remember this is a weak acid versus a strong base. And the indicator you always use here is phenolphthalein. Bonus points if you spell it right. The reason for that, the colour change, or the pH range of phenolphthalein, lies or coincides with the vertical part of the curve. And the pH range of phenolphthalein is 8 to 10. So it lies within that. So 8 to 10, there we go. It's within that vertical part. Yeah, so the colour change or the pH range lies within the vertical part of the curve. And we can see that it gets vertical. My volume of base at it, generally around here. 19 all the way down to 20.5. We can see the pH going from 11.1 to 6.2. So 8 to 10 does definitely lie within that. But you can see it better in the graph. Another one here, 2013, question 11. To find a base according to the Arrhenius theory. So a substance that associates in water forming hydroxide ions. And a Bronsted-Lowry base is a proton acceptor. So again, your bread and butter. Give the conjugate acid of HPO4 2-. Now when we're thinking of acid, we're thinking of added. So add on a H+, so we add on a hydrogen, H2PO4-, because we're adding on a plus charge. And the conjugate base, just the opposite. Instead of adding on a H+, take away a H+, and we've got PO4 3-. Ammonium hydroxide is produced. Calculate the pH of ammonium hydroxide. Now it's a base because they're giving me a Kb value. So slightly different to this. What I'll initially work out is my hydroxide ion concentration is the square root of Kb times Mb. Only problem is I don't have my Mb, which means moles per litre. But they provide me with enough information. They say it's 7 grams per litre of NH4OH, ammonium hydroxide. When I can bring it back to moles. To go back to moles, I divide by its relative molecular mass. Mass number of carbons 14, 5 hydrogens, and 1 oxygen. When you sum those up, you get 35. So 7, divide that by 35, gives you 0.2 moles per litre. Now, hydroxide ion concentration there. It's the square root of 1.8 by 10 to the minus 5, is it? Yeah. Times 0.2. You work that out. And we get 3.6 by 10 to the minus 6. What are you going to do then? Is your POH is minus log to the base 10 of my hydroxide ions. Just never delete that answer. .44. Something's not right there. 28 by 10 to the minus. Oh, I forgot to take the square root. Because that's fair, eh? What's wrong? Just testing these watching this video. And also there's a pizza arrived at the door. So I'm rushing it. 1.9 by 10 to the minus 3. Now, POH is minus log to the base 10 of that. Back on track now. 2.72. And then to work out my pH has to be above 7. It's 14 minus that. Which gives you what? It's taking me too long. 11.28. That's it. I'm going to stop it here now. Get something to eat.